So we're going to take a look here at another example of that last type of example from class today, except now I'm going to say find the term including x cubed and the expansion of this fifth binomial to the fifth power times this other binomial. So first things first, I know I'm going to have to start expanding this guy. And I can use the binomial expansion theorem and say my a to the fifth plus 5 choose 1 a to the fourth times b plus 5 choose 2 times a to the third b squared, and so on, and have my expansion here as such. Notice I'm leaving my x minus 4 outside and saying just expand this guy first. So I have 3x. Notice the parentheses. I do need these because this means 3 to the fifth times x to the fifth. This is 32x to the fifth, not 3x to the fifth. And I have my 5 choose 1 a to the fourth b, adding my 5 choose 2 a cubed b squared. Again, I can double check and say 3 plus 2 is 5, okay? 5 choose 3 a squared b cubed, and so on. Now I'm saying and so on because really all I'm looking for is this x cubed term. And I know that I'm going to end up multiplying x by each term. X times this term, x times this term, x times this term, and so on all the way through. And keep adding those together, and I'm going to still have to add negative 4 times my first, negative 4 times my second, negative 4 times my third, and so on. But I'm only going to get two terms that have an x to the third power. Notice how this is the only one to the fifth, the only one to the fourth, the only one to the third, except I'm going to multiply it by each of these guys. So I have to ask myself, what am I going to multiply by x in order to get to x cubed? So I think about it, I go, well, x times what gives me x cubed must be x squared. Right, so I scan my terms, I find my x squared term, I say, wait a minute, he is going to have a constant, something with an x squared in it. So I'm going to map these guys together. I'm going to say x times this whole term is going to have an x cubed in it. And I say, well, that's great, but I also have this negative 4. This negative 4 is going to be multiplied by each term. What times negative 4 is going to give me something including an x cubed? And so I say, well, if I only have a constant, it has to multiply by an x cubed term. So I notice this guy's got an x cubed, right? Constant, x cubed, right? So I'm going to map these two guys together. And so rather than having to expand all of this and add all of these terms and then determine which ones actually have an x cubed, I can say x times this guy and add my negative 4. Notice my b here is negative 4, not just 4, times this guy. So I'm going to write that down. I'm going to say x times all of this and negative 4 times all of this and add them together. And then I have some simplifying to do. I can say, well, 3x squared is really 9x squared, right? This is 3 squared x squared. I can also say, well, wait a minute, my x and my x I'm going to put those together to make sure I can multiply them out. And same here, I can say quantity 3x cubed is 3 cubed x cubed. So I'm going to write that in this next step. Notice I just squared my 3, I squared my x, and then I moved this guy, since I can move around numbers, right? 2 times 3 times 4 is the same as saying 2 times 4 times 3. Order doesn't matter if I'm just multiplying. So I just moved him over so I can see this guy forming, this x cubed forming here. Right? And here I just said 3 cubed, x cubed. That's all I did here. Now I can actually do that simplification. I can say in my calculator 5 choose 3, or I can use that formula that we know, n factorial over r factorial times n minus r factorial. Or if you recall from class, if I have 5 shirts and I have 3 that I want to choose, there are 10 ways to do that. So I know that's 10. I know 3 squared is 9. I know x squared times x is just add my exponents, right? X cubed. 2 cubed is 8. Negative 4 is fine, and I know that as we learned, we said 5 choose 2 is the same as 5 choose 3 is 10. 3 cubed is 27, x cubed is fine, and 2 squared is 4. So I'm going to substitute these integer values in here. 9, x cubed, I simplified here, 8, negative 4, 10, 27, x cubed, and 4. And now I'm starting to look more familiar. Now I can actually say this. Well, if I have 10 times 9 times x cubed times 8, I can say that's 10 times 9 times 8. and then put it in front of x cubed, right? So multiplying those three numbers. And similarly, I can say multiplying here, I'm going to say negative 4 times 10 is negative 40. Multiply that by 27, multiply that by 4. I end up with 720 x cubed, and I get a negative from here, 4320, x cubed. So I have 720 of something minus 4320 of something. I subtract those constants out front, those coefficient values. I get negative 3600 x cubed. So that's going to be the term. And I look back and I say, well, it asks me to find the term including x cubed. That's my actual answer. Negative 3600 x cubed is the term including x cubed. However, if I would have asked for a coefficient, like our homework problems mostly do, or homework problems say the coefficient, I don't want negative 3600 x cubed. All I want in this case is negative 3600. So if it asks for the coefficient, I just want that number out front. If it asks for the term, I want the whole thing. Right? So now that was another review of this type of expansion problem, so that you can do that for your homework problems as well as for that review set. So to make sure that I get that homework done from Friday, as well as my review set from E-Day, so that I'm prepared to go over this material Tuesday and quiz on Wednesday. Have a most blessed weekend, and I hope this helps.